Hi, my name is Marco Kellner and this is my lab submission for the unknown mass of a black hole. In this lab, we'll be combining concepts that we have learned with the fundamental principle of Newton's second law. We are given the mass of a star revolving around a black hole, and with the given position data, we'll instruct VPython to calculate velocity and use that velocity to calculate momentum using Newton's second law. As we know, Newton's second law equals to F net equals mass times the derivative of velocity over the derivative of time. With the calculated information, we will be able to deconstruct the momentum into parallel and perpendicular components, and since momentum already takes mass into account, we can figure out the F net. With the F net, we can plug it into Newton's gravitational force law, shown here, to figure out the unknown variable that we are looking for, which is the mass of the black hole. Now we move on to the coding section of this lab. Every student is given a different randomly generated position data. We link this into our starter code and it visualizes where our star moves like this. Now we change the initial conditions and set the star's mass and define delta t for a year measured in seconds. Now we get to the actual calculation part. We instruct VPython to calculate the initial and final velocities by using the updated positions. Then, using the velocities, we multiply those by the mass to define momentum, written as p initial and p final. After knowing this, we can define delta v and delta p. Next, we use the change in momentum to specify dp dt so we can assign the change in momentum over time as the net force. After specifying the net force, we try to break it down into its parallel and perpendicular components. We want to know its perpendicular component because it indicates with how much force the star is being attracted to the black hole. If we know with how much force the star is being attracted to it, we can work on Newton's gravitational law backwards to figure out the mass of the black hole. Therefore, we know that the parallel component plus the perpendicular equals to the motion. So we assign dp dt perpendicular as dp dt minus dp dt parallel and make that equal to the F net perpendicular. To complete the equation, we need the distance squared between the two bodies. So we specify it as distance equals star.pos minus the vector of the position of the black hole. Now we can calculate for mass, which gave us a big number but was significantly smaller than our star's mass. Now, for the question of what does it mean, we specified that dp dt equals to F net, but dp dt equaling to F net is something derived from the momentum principle, and that dp dt is something that we can calculate with the changes in position, while F net is the force causing the changes in position and is not something we can measure directly. For the what if question, if a different black hole was placed in the same location and the motion of the star remains completely unchanged and unaffected by the gravitational force of the new black hole, could we tell the difference? And the answer is no, we couldn't tell the difference because the thing is following the same trajectory, and it would just mean that the force is the same because if the force was different, then the position would be different because the movement would be affected. Thank you for watching, and I hope you learned something new today.